This video is over the quiz review from section 5.1 and 5.2. There are three kind of things that are on here. We have a general probability distribution, which is number 1 and 2, and then we're using the binomial distribution, which is our pink table, and then we are using the geometric distribution, where we have our simple formula. So the first one here is just a general probability distribution. So if we want to find P of X is 2, this is as simple as we just look right in the chart and we see our 0.16. If we want 11 or 14, the same thing, we get our two numbers in the chart. And remember, if we have 11 or is add, we just add them together to get 23. The next question uses the binomial table, so we're using our pink tables to answer this question. And we have the information that N is 9, P is 0.45, so we're just looking those up in the table. If we have X equals 1, you're just going to N is 9, X is 1, go across to 0.45 to get your answer. X is 6, same thing, we get 0.116. A little more involved when we have greater than and less than. If we have less than 3, that is going to be 0, 1, and 2. So we just look up those three numbers in the table and we add them together to get 0.15. If it is greater than 6, this greater than or equal to, this would be 6, this would be 7, this would be 8, and this would be 9. Once we add all those together, we get 1.66. If we have less than 7, so you could do less than 7 by finding what's 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6, and you can add up all 7 of those numbers to get your answer. Or an easier way that we've looked at before is you can just look at the ones greater than 7, 7, 8, and 9, add them up, and subtract from 1. Both ways will work. Both ways give you the same number. You're just looking at which one maybe would be a little bit easier. 1, for you to understand. 2, to do all the calculations. If we have the probability that X is greater than or equal to 1, if we think about looking at our chart, you would have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Greater than or equal to 1 is from here all the way down. So we could add all these up. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Or an easier way is to just do 1 minus the 0, which is what we did here, to get our number. Adding up all 9 numbers will work. It'll give you the same answer. It just may take a bit more work. Now, the rest of these problems, one of the first things you're going to look at is you're going to have to decide, is this a binomial or is this a geometric? And then that's going to kind of tell you what to do. If it's binomial, we're using our table. If it's geometric, we're using our formula. So as a special promotion for 20-ounce bottles of soda, a company printed a message on the inside of the cap. Some of the caps say, please try again, while others say you're a winner. The company advertises the promotion with the slogan, 1 in 5 wins a prize. Kramer decides to keep buying 20-ounce bottles of soda until he wins. So this is, you keep trying until you get a winner. You keep trying until your first success. So this is geometric. And our formula for geometric is P times 1 minus P to the n minus 1. All right, once again, that's on our formulas. So if 1 in 5 is a winner, that means 1 in 5, 1/5, is 0.2 is our P. So what's the probability he has to buy exactly 3 bottles before getting a winner? Let me write a little bit bigger here. Remember, our formula is P, 1 minus P, which is our Q, to the n minus 1. So our P is 0.2 to the 1 minus 0.2. This should be right there. and that gives us our answer of 1.28. If we say, what's the probability he'll get a winner on the first bottle, it's the same formula. All that we have done is, instead of having 3 in the formula here, we have 1 in the formula there. That's all that changes. So the next question, what's the probability he'll have to buy 3 or fewer? That is 1, 2, 3. Now, one of the things I'll mention here, when we were looking at binomial up here, for binomial, you can have a 0. Because in binomial, if you're doing something, a fixed number of trials, if you are doing something 9 times, it's a possibility that you never get a success. It's a possibility that you never hit a target. You never make a basket. That's possible. But here we are looking at how long until we get the first success. And you can't have your first success without ever doing a trial. So for geometric, they always start at 1. You can't get a 0. You can't make your first basket if you never shot a basket. So now if we want 3 or fewer, we have to find the probability of 1, that's 0.2. The probability of 3, that was 1.28 up here. And then the probability of 2, we got to figure out the formula. We add all these together, and we get 0.489. Let me not show this. It's reported that 80% of all business startups in the IT industry report that did generate profit in their first year. If a sample of 10 new business startups is selected, find the probability exactly 7 will generate profit in the first year. So what you're trying to decide here is this binomial or geometric? Are you looking for a fixed number of trials and a set number of successes? Or are you looking at how long until your first success, and the number of trials is your probability? So this one has 80%, 10 trials, and then exactly 7. So that is binomial. So you're looking this up. This is from the table, and you're getting to that number. A computer company determines that 0.2 of computer parts are defective. Find the probability the first defect is found on the 7th component tested. So you're trying to see, are they looking for multiple successes or the first success? They are looking for the first defect is found on the 7th. That is geometric. So once again, our formula, P times 1 minus P to the n minus 1, and we get our answer. A box of candy has many different colors in it. There are 15% chance of getting a pink candy. What is the probability that exactly 4 candies in the box are pink out of 10? So are you looking for a first success? Nope. You want exactly 4, which tells us this is binomial. So once again, we're just looking this up in the table. So we're either binomial in the table or geometric in the formula. According to a college study, 45% of all students live off campus. For a sample size of 12, find the probability that exactly 7 live off campus. Looking for the first one? Nope, we're looking for 7. This is binomial. This is once again in the table. On campus, find the probability that you have to ask 3 people until you find someone that lives off campus. Ask 3 people until you have found someone. This is the first person, so to speak, that lives off campus. That makes this geometric, and so we have this formula here to get 1.36. All right, that is the review for the quiz tomorrow. Remember, you are allowed to use your notes, so you can use this notes, and obviously you're allowed to use your pink sheet because we have to use the table on the quiz. All right, you now should be ready to take your quiz tomorrow.